So we'll just get these mounted then with a bit of magic. Wow. So hi everyone and welcome back. Now I can finally announce the launch of this new wheel set that I've been testing for a fair few months now. They are a new product from a company based in Singapore, the founder of which is a mechanical engineer himself, and I've been testing these in all sorts of conditions for a fair few months, relaying my thoughts back to him. Now they've got a fairly small production capacity at the moment, but they're looking to increase that in the coming months. The design philosophy behind these wheels was to make a very deep wheel, obviously, which is aerodynamically superior, but one which remains very stable and predictable in all windy conditions. Now, discussing with the founder of the company, he's accepted that wind tunnel data and fancy yaw graphs, drag graphs, are not the be-all and end-all. It's not always tangible to understand those and kind of compare them to real-world conditions. And he's accepted that, so he just encouraged me to do as much outdoor testing as possible and give all my opinions, which yes are very subjective and it's conjecture, but I'm not just going to sit here and pump a load of wind tunnel data at you, because I think the market is just wisening up to that. But we did discuss that, you're damned if you do and you're damned if you don't publish that stuff. So that stuff is on the website. These have been wind tunnel tested in the US, but I prefer just to test them and get my feelings on the road. Now a lot of people dismiss having very deep wheels because they think it's unstable or dangerous even in crosswinds, but can you achieve that holy grail of a very fast deep wheel and one that remains very stable? Well, let's split those two things up for a minute and discuss what a deep rim does and why it's faster, and then we'll talk about how you get stability. So one fundamental reason a deep rim is faster is because there's more area where the air only touches the rim once. So if you think about this bottom segment of the wheel and this top segment of the wheel, the deeper the section, the more area the air can flow over it without having to reattach at the back of the rim and then attach again when it hits that side of the rim. So, and obviously that's the same principle behind a disc wheel. So if you can push that area up, you're not asking the air to do so much work. If you've got air trying to reattach here, it has to flow over all of this mess, the spokes and everything, before trying to attach at the back of the rim again. The deeper the rim, and this is particularly poignant on the front, the deeper the rim, that larger the segment of that circle where the air only has to touch the rim once, and that's one reason why deep rims are much, much faster. Now the benefit is much larger than just the proportional increase in rim depth. So a small increase in rim depth, let's say from a 50 to a 69mm rim like these are, yields a huge increase in area where the air doesn't have to flow over the rim twice. The comparison can be realised basically just by comparing the segment areas of each rim. And for instance, I'll put the little bit of math on the screen here, but for a 50mm rim versus a 69mm rim like we've got here, that area goes up by 61%. So over a 50mm rim, these have a 61% larger area where the air stays attached to the rim once. It doesn't need to come off that trailing edge and reattach to that leading edge, and that's all basically just segment area rule. That's pretty standard. I'll put the the math on the screen here. But that's one reason why a really deep rim is faster. Stability. It's really important to understand that stability versus steering moment are two different things, or stability versus side load or side force are two different things, and we've got to understand that. Of course, a much deeper wheel will catch more wind. It's got a much larger sail area. But can it remain stable and predictable at stall or in transient gusts? And if it can, well, there are very few drawbacks to having a much deeper wheel. So is this wonder condition actually achievable? Well, so far I'm pretty impressed by these wheels. Yes, you can really feel quite a large force, quite a large side force building up on the bike, but it feels very linear. Of course that's all subjective, but they do not feel twitchy in any way. And the good thing is, because they're so deep, and actually they're quite wide, so I've got quite a wide 28mm tyre mounted to the edge, they have a bit more inertia than a very lightweight deep wheel, which means when the gusts let go or the wheel does stall, everything comes back together and comes back to centre a bit more calmly, versus a much lighter, shallower rim. Now the construction, it's a very, very fat rim. It's 23mm internal, which means a 28mm GP5000 balloons up to over 30. I think the widest point on the external of the rim is over 30 again, but yeah, 69mm deep, 23mm internal, so they're very wide. I was a bit skeptical at first, but I'm really enjoying the extra comfort that gives on the back. I'm not so sure about this wider tyre, better comfort and better rolling resistance thing. I think you can have one or the other. If you talk about ISO skin tension, I don't think you get a free lunch there. I think the front wheel could be a bit narrower, For the price you're paying for these wheels, I think it would be nice to have a front and rear specific design, because obviously, the engineering problem of the front wheel was very different to the rear wheel. It sees a much higher free stream velocity from the oncoming air. It supports less of the rider weight. So, it'd be nice to have a bit less frontal area on the front rim versus the rear, and probably go down a tyre size. So back to a 25mm on the front, I think would be great. I've never really complained about the front end comfort of a bike. Most of the discomfort you feel in a stiff race bike, for me, always comes from the rear of it and the seat post deflection and the tyre size on the back. So I'd stick with a really, really fat one on the back where the free stream velocity is much lower, but it might be better to have a slightly narrower, lower frontal area on the front. But whether that messes with the stability design, the specific design of this, then maybe that's why they've stuck with it. But the skeptic in me, if you make a front rim mould and a rear rim mould, your tooling investment break-even point goes up by a factor of 2-ish. So that's the skeptical explanation of why they've done that. But it would be nice, I think, to have a slightly narrower front wheel. But I can't say I've noticed any speed decrease in the extra frontal area. I don't think there's an aerodynamic penalty, really. I can't feel it. I can't really measure it. It's so small. Other things I could mention, when you get buying a wheel set at this price, this is a pet peeve. Having to cover the valve with a bit of electrical tape to stop it rattling is kind of like, it's not really on, is it, in 2022? This is an expensive high-end wheel set, and that's just an afterthought. Why can't they design something in? I'll put a little thing on the screen, maybe, some idea I had. You can thank me later for that. Now, pricing, I think the bottom end one, the DT350 option, starts at about $1,600 depending on your conversion rate from Singapore dollars. This version here is about $2,000, and then quite a lot more for the DT180 in carbon spoked offering. Now, that I would say is at the top end of what's on offer in the Far East in terms of the other kind of up and coming brands. But you won't find this rim shape anywhere else. They do have, proprietary use of this mold. So this is an invested mold by the company, and yeah, it's I think it's quite unique. And what I haven't mentioned yet is the weight of these wheels. So considering the depth, they're 69mm, the weight is seriously impressive. So this disc set here weighs 1600 grams. Considering how much carbon is in these wheels, 69mm deep, 23mm internal, 30mm external, that's actually really impressive. And they've done that by using a lot more high mod fibers instead of the lower grade, lower modulus fibers, so they can put a bit less carbon in and get the weight a little bit down. What that does to the impact toughness of the wheels, well, they're still, still tested, still fatigue tested to the UCI conditions, which isn't the, most stringent a test, but the weight, I have to say, is very impressive. The rim brake variants are about 50 grams lighter. If you do go for the rim brake variant, though, you need to check the clearance through the calipers, because it makes the tyre so big, and the rim itself is very fat. You need to check you've got adequate clearance. So I hope you enjoyed that. Post any questions down below. I can relay them to the company. And yeah, see you in the next one.